Good evening, sir. It's my great immense pleasure to welcome our research person, Dr. Dadheech, on the topic of mobile application security. He's currently working as associate professor and deputy head in the Department of CSE at Swami Keshavanand Institute of Technology and Management and Gramothon, Jaipur. Received his BE in CSE from Gyan Vihar School of Engineering and Technology and also holds MTech in CSE from Purnima College of Engineering and Technology, Jaipur, and received his PhD in CSE from Suresh Gyan Vihar University, Jaipur. And here's one of the top performing mentor for the SWAYAM NPTEL online certification course and recognized as Gold Partner Faculty under Inspire the Campus Connect Faculty Partnership Model of Infosys Limited in the years 2014 to 17 and awarded as a certificate of recognition for Microsoft in education. Thank you so much, sir.
Thank you, ma'am.
The session will be continued by Dr. Pankaj. Sir, is it audible?
Dr. Pankaj, you can share your screen, sir.
Hold on, sir. Just 1 minute. Yes, it is visible, sir.
Your screen is visible, sir. Please, just now, I think.
Yes, sir. It is visible. Hello.
Visible, yes, sir. It is visible. Please proceed.
Okay. So today I will discuss about mobile application security. This is the topic, very hot topic. So what is mobile cloud computing? So you can see the mobile cloud computing is the simplest and refers to an infrastructure where both the data storage and data processing happen outside the mobile device. So mobile cloud applications move the computing power and data storage away from the mobile devices and into powerful and centralized computing platforms located in clouds, so which are then accessed over the wireless connection based on a thin native client. So why mobile computing? Actually, we are using mobile computing for various mobile devices which face many resource challenges like battery life, storage, bandwidth, etc. And the cloud computing offers advantages to users by allowing them to use infrastructure platforms and software by cloud providers at low cost and elastically in an on-demand fashion. So mobile cloud computing provides mobile users with data storage and processing services in clouds and the need to have a powerful device configuration, for example, CPU, speed, memory capacity. So as all resource intensive computing can be performed in the cloud. So we use mobile cloud computing. So this is the mobile cloud computing architecture where mobile network A is there and mobile network B is there. So some mobile network services like satellite, access point, mobile devices are using these and through BTS and central processor servers databases. So these are the various setups for mobile network A and mobile network B and connected to the internet, where the various mobile users connected with network operators and ISPs are there, internet service providers are there, and then the application service providers where the cloud computing or cloud controller is there and the data center is there. So this where the data center owners or cloud service providers provide these services. So this is the mobile cloud computing architecture. So you can see the mobile devices are connected to the mobile networks via base stations and that establish and control the connection and functional interfaces between the networks and mobile devices. You can see in this figure. Then the mobile users request and information are transmitted to the central processors that are connected to servers and providing mobile network services. So the subscriber request and delivered to a cloud through the internet, and in the cloud controllers process the request to provide mobile users with the corresponding cloud services. So what are the advantages of mobile cloud computing? So you can see the extending power lifetime where computation offloading migrates large computations and complex processing from resource limited devices, for example, mobile devices, to resourceful machines, that is servers in cloud. It extends the battery life. And another is the remote application execution can save energy significantly, and the many mobile applications take advantage from task migration and remote processing. So these are the advantages of mobile cloud computing. Then second is improving data storage capacity and processing power, where the mobile applications are using the storage capacity, and this is not the constraint by the storage capacity on the devices because the data now is stored on the cloud. So it enables mobile users to store access large data on the cloud, and it helps to reduce the running cost for computation intensive applications. Third advantage is the improving reliability and availability. So the data is available all the time and it is will be reliable. So the keeping data and application in the cloud reduces the chance of loss on the mobile devices. So in no case the data will be lost. So mobile cloud computing can be designed as a comprehensive data security model for both service providers and users. So it protects copyrighted digital content in cloud and provides security services such as virus scanning, malicious code detection, authentication for mobile users. And with data and services in the clouds, then are always almost available, even when the users are moving. So it is high availability. It is means the data will be available all the time. Another advantage are dynamic provisioning and scalability. So dynamic provisioning, where the dynamic on-demand provisioning of resources on fine-grained and self-service basis there, and no need for advanced reservation. And in scalability, the mobile applications can be performed and scaled to meet the unpredictable user demand. Means it can be scalable on the user demand. So service providers can easily add and expand a service. Another advantage are multi-tenancy and ease of integration. So in multi-tenancy, the service providers can share the resources and cost to support a variety of applications and large number of users. And ease of integration means multiple services from different providers can be integrated easily to the cloud and the internet to meet the user's demand. So another application is mobile commerce. So m-commerce allows the business models for commerce using mobile devices. For example, mobile financial or mobile advertising or mobile shopping. So m-commerce applications face various challenges like low bandwidth, high complexity of devices, security. So it is integrated with cloud and can help address these issues. And another example is combining 3G and cloud to increase the data processing speed and security levels. Then another application in mobile learning where it combines e-learning and mobility. So traditional M-learning or mobile learning has limitations on high cost of devices, network and low transmission rate and limited educational resources. So cloud-based M-learning can solve these limitations and enhance communication quality between students and teachers are there. And it helps learners to access remote learning resources, and it provides a natural environment for collaborative learning. Another application in mobile healthcare is already discussing in previous session about healthcare. So healthcare is to minimize the limitations of traditional medical treatment. For example, small storage, security, privacy, or medical errors. So mobile healthcare provides mobile users with convenient access to resources or medical reports. So mobile healthcare offers hospitals and healthcare organizations a variety of on-demand services on cloud. So, for example, it is comprehensive health monitoring services or intelligent emergency management system or health-aware mobile devices to detect like pulse rate or blood pressure or level of alcohol and the pervasive access to healthcare information and the pervasive lifestyle incentive management to manage the healthcare expenses. So these are the various mobile cloud computing applications. Another one is mobile gaming, where mobile gaming is a high potential market generating revenues for service providers, and it can completely offload game engine requiring large computing resource. For example, graphic rendering to the server to in the cloud, and offloading can also save energy and increase game playing time. So it renders application technique and can dynamically adjust the game rendering parameters based on communication constraints and gamers demand. Another applications are assistive technologies like pedestrian crossing guide for blind and visually impaired persons, and mobile currency reader for blind and visually impaired, or lecture transcription for hearing impaired students. So these are the assistive technologies where mobile cloud computing plays important role. Another applications for sharing photos or videos, or the keyword based or voice based or text based searching is there, or in monitoring a house or a smart home systems, the mobile cloud computing applications are using these. So these are the various applications. Now, what are the mobile cloud computing issues? So you can see mobile communication issue like low bandwidth is there. So one of the biggest issue it is because the radio source resource for wireless network is much more scarce than wired networks, and the service availability where mobile users may not be able to connect to the cloud to obtain a service due to traffic congestion or network failure or mobile signal strength problems like this. Another issue is heterogeneity. We are handling wireless connectivity with highly heterogeneous networks to satisfy mobile communication issues requirements like always on connectivity, on demand, stability, energy efficiency. It is a difficult problem for mobile cloud computing. So these are the various mobile communication issues: low bandwidth, service availability, and heterogeneity. Another is computing issues where computing offloading. It is one of the main feature of mobile cloud computing where offloading is not always effective in saving energy, and it is critical to determine whether to offload and which portions of the service codes to offload. So there are two types of offloading. Sorry. Offloading in a static environment and in dynamic environment. So then another mobile cloud computing security issues like protecting user privacy, data application secrecy, and adversaries is key to establish and maintain consumers' trust in the mobile platform, especially in mobile cloud computing. And the mobile cloud computing security issues have two main categories, uh, like security for mobile users, securing data on clouds. These are the various security issues. Then security for mobile users. So mobile devices are exposed to numerous security threats like malicious codes and their vulnerability. So GPS can cause privacy issues for subscribers. And the security for mobile application for installing and running security software to detect security threats or mobile devices are resource constrained, where protecting them from the threats is more difficult than that for resourceful devices. So mobile user security approaches where overhead it present an approach to move the threat detection capabilities in cloud, or the major component of cloud area is the network service that is responsible for file verification, for privacy issues in mobile cloud computing. So the location-based services (LBS) it faces a privacy issue on mobile users and provide private information such as their current location. So this problem because becomes even worse if an adversary knows users' important information. So it is the another issue. Then context-aware mobile cloud services. So it is important to fulfill mobile user satisfaction by monitoring their preferences and providing appropriate services to each of the users. And context-aware mobile cloud services try to utilize the local context. For example, data types, network status, device environment, and user preferences to improve the quality of service. Then open issues in mobile cloud computing is network access management, where efficient network access management not only improves link performance but also optimizes bandwidth usage. Then cognitive radio can be expected as a solution to achieve the wireless access management, and it can automatically changes its transmission or reception parameters in a way where the wireless communication can have spectrum agility in terms of selecting available wireless channels and opportunities. So, integrated with mobile cloud computing for better spectrum utilization. Another is quality of service. So, how to ensure quality of service is still a big issue, especially on networking. So, clone cloud and cloudlets are expected to reduce the network delay, and clone cloud uses nearby computers or data centers to increase the speed of smartphone applications. So, idea is to clone the entire set of data and applications from the smartphone onto the cloud, and to selectively execute some operations on the clones and reintegrating the results back into the smartphone. So, a cloudlet is trusted and resource-rich computer or cluster of computers which is well connected to the internet and available for use by nearby mobile devices with one hop wireless communication. So, mobile users may meet the demand for real-time interactive response like one hop or high bandwidth wireless access to the cloud net by low latency. So, it can help mobile users overcome the limits of cloud computing as well latency and low bandwidth. Then pricing, where mobile cloud computing involves with both mobile service provider MSP and cloud service provider CSP, with different services management, customers management, and methods of payment and prices. So this will lead to many issues. So the business model, including pricing and revenue sharing, has to be carefully developed by MCC. So standard interface where interoperability becomes an important issue when mobile users need to interact with cloud. So web interfaces may not be the best option. So it is not especially designed for mobile devices and may have more overhead. So compatibility among devices for web interface would be an issue, and the standard protocol signaling an interface for interacting between mobile users and cloud use would be required for like HTML5 or CSS3 like. Then service convergence. So services will be differentiated according to the types, cost, availability, and availability and quality. So the single cloud may not be enough to meet mobile user demand. So new scheme is needed in which the mobile users can utilize multiple cloud in a unified fashion. So this scheme should be able to automatically discover and compose services for users. So sky computing is a model where resources from multiple cloud providers are leveraged to create a large scale distributed infrastructure. So the mobile sky computing will enable providers to support a cross cloud computation and enables users to implement mobile services and applications. So service integration, that is convergence, would need to be explored. So mobile development security. So app security constraints are the built-in security features of the mobile platform and possibility of device theft. So the threat modeling, where identifying security risks, it helps developer to identify most critical risks, and it is focuses on features and or controls to mitigate those risks. So the alternative is endless and aimless and bug squashing. So the threat modeling technologies from 1999, we can see that like open source it began in 2006, and more traditional risk management philosophy is to be done. So the another technology is Octave, where operationally critical threat, asset, and vulnerability evaluation from CERT, and then another is digital threat modeling. It is based on software architecture, and another one is TASTA, which is the process for attack simulation and threat analysis. So these are the threat modeling technologies, the threats. So app hacking tools are there, or Bluetooth or 801.22 attack. So injecting code into a mobile browser, man in the browser, MITB like this, or another, you can see the malicious apps where malware and trojans are there, or femtocells which observe all the traffic. These are the various threats from, so threats from phones user. So first download your app and reverse engineer it. So jailbreak the device or subverting control you depend on. So thieves may steal the device and gain access to the UI and physical interfaces such as USB. So these are the threats from users. So users as threats where what evil or insidious things could a user do. So steal encryption keys or credentials from applications or reverse engineer apps are there. So what obnoxious or stupid things could a user do to cause trouble? So these are the user as threats. Other device owners as threats like stakeholders like to app store account owner or a publisher who provides the user experience or mobile carrier, for example AT&T or device manufacturer like Samsung, etc. App Store Curator, where Apple, Google, Amazon are the App Store curators and company IT department that administers the device. Another importance of other stakeholders is to operate apps and underlying software. It control credentials and operate services. It carries and handset manufacturers place apps on the device and it may customize the operating system and may place code beneath the operating system in firmware. Another is importance of other stakeholders where app store curators control a large portion of the app cycle through packaging and deployment, update and removal. When stakeholder goals differ, so opportunity for one owner to do something and that another stakeholder considers a and assets where each stakeholder protects its assets, so end user may value privacy. A publisher and carrier want to collect and use personal and uses information. Types of data where offline access available where phone is not connected to a network. Personal data, contacts like or through voicemails or sensor-based data where location data, GPS or tower telemetry or camera, microphone data is shared. Then identity data where app publishers are reluctant to force users to authenticate using small virtual keyboards. Identify data includes persistent credentials or DNA tokens such as authorization, usernames, device user or application.
இல்ல ரொம்ப
Then
சவுக்கிற
username.
மாதிரி இருக்கும்
So
அதனாலதான்
if a web-based service uses a mobile device for out-of-band password reset and the user has an app for that service, so attacker with a stolen phone can reset the password. Then threat modeling, so it derives the attack surface and potential attacks, it lists assets and stakeholders and brainstorm how each stakeholder might cause a security or privacy breach for another. And it prioritizes attacks by likelihood and impact and it implement mitigations and use the list of attacks to drive secure software development lifecycle. Then threat modeling where mobile app has two main components, mobile client and mobile web services that support it and both can be attacked through threat modeling. So native APIs or mobile web where API is written specifically for the platform using native APIs and it takes full advantage of the platform features, user interface consistent with platform. Then mobile web apps where it's the same as web app and but optimized for a smaller screen and cross-platform mobile development frameworks try to provide the best of both worlds. Then device and runtime environment integrity. So where how can an app ensure that the operating system has not been modified or even the app itself. So mobile device management is there, so it provides some assurance and app integrity protection is there where anti-debugging and code obfuscation is there. So limitations of integrated assurance where if a device is jailbroken or rooted, mobile application management is there and maintaining patch your app through the app store and the main channel for updates. So secure mobile app guidelines where traditional web application security is there, storing sensitive data on the device. Avoid it to and mobile device sensitive data, security hardware, security platform storage, mobile databases and file system precautions. These are the various security considerables for storing sensitive data on the device and authenticating to mobile services where authorization and authentication protocols are used, or always generate your own identifiers or implement a timeout for test credentials. Secure communication use only SSL, secure socket layer or transport layer security TLS, and validate server certificates and use certificate pinning for certificate validation. And for web view interaction, web view cache and web view JavaScript visors are there for security consideration, and preventing information leakage, clipboard logs are there. So secure mobile app guidelines where additional iOS uses the traditional C application secure coding guideline, keyboard case or enable full ASLR using by, or for Android platform specific, you can use these guidelines like traditional C++ Java application secure coding guideline, or these secure NFC guidelines are there. So secure more mobile app guidelines where web app security is there, and create a walled garden where it request or redirect or legacy contents may be aggressively cached by mobile browsers. So these are the various how you can create a walled garden, or reduce the session timeout for mobile devices where greater risk of MITM attacks or greater risk of device theft is there, and use of secure JavaScript subset is there. So mask and tokenize sensitive data where mobile devices have aggressive data caching, increased risk of data exposure, and storing sensitive data on the device where avoid storing sensitive data when possible, and it places the to store data strongest to be cached. So security hardware is there, security platform storage can be used, and mobile databases and file system. Then mobile device sensitive data where personal data can be like contacts, pictures, call data, voicemail, sensor data like GPS, camera or microphone, or identify data where persistent credentials, bearer tokens, usernames, device, user or application specific UUIDs. Then security hardware where secure element microprocessor is used for mobile payment system, access using existing smart card standards, and lockout for 5 to 10 failed pin attempts, or but general purpose applications does not have to access the secure element. So secure platform storage where Apple's keychain SQLite database is using protected by an operating system service with that limits access of keychain items. For keychain weakness, root user can read everything in the keychain, or Android key store where intended to store cryptographic keys has no inherent protection, or app must provide a mechanism, or mobile databases where database can be encrypted with a single secret with third-party extensions like a SQLite, to SQLite like SEC, SQL Cipher, CD-ROT, and file system protections in iOS where default encryption of files on the data partition, centralized visible metadata, or cryptographic linking to a specific device, or enabling by default in iOS 5 and above, and Apple iOS security. Then file system protections in Android where files stored in internal storage are private to the app that created them. Then files stored in external storage, Android 3.0 and later provides file system encryption. Then secure NFC guidelines. So don't trust data from NFC tags, or perform input validation and write protected tag before it is used to prevent it from being overwritten. So these are the various secure NFC guidelines. And for test your controls, make sure everything setting is really working. Then mobile code, it is a software agent that programs that act on behalf of their creators. So mobile code agents are software code or agents that have the ability to travel from one place to another to do the work assigned to them autonomously. So the data where the agent mobile code is working on the code. So advantage of mobile code where the better network performance and visualization. Another advantage is automation of a sequence of tasks on different location, and distribution and update of the software packages. So the various mobile code agent applications are like data collection from many places. Other advantages are applications are these: searching and filtering, monitoring, target information, dissemination, parallel processing, e-commerce, entertainment, negotiating. These are the various mobile agent applications. Then mobile code security. So in the past, mobile code was machine dependent and could only run on very specific machine architecture. So today this is not the case. We are becoming increasingly vulnerable to malicious attacks and defective software roaming the internet. So security of mobile code is emerging as one of the most important challenges facing computer research today. So basic concepts are like trust. So security is based on the notion of trust, and basically software can be divided into two categories. Trusted software where all software from our side, and untrusted software where all software not from our side. So it is third party software. Then safety policy. So a code is safe if it follows the control flow or memory and mistake safety. So mobile code security dimensions were protecting the host from malicious mobile code, like from, for example, sandboxing, code signing, firewalling, proof carrying code, and protecting mobile code from the execution environment like active and passive attacks. So protecting the host, so there are various ways by which a malicious agent can harm the host, and an agent may steal or manage to get illegal access to some private data. For example, financial data of a company from a database residing on the host, and an agent may damage or consume the host resources like deleting some files or consume a lot of processing power or network bandwidth or cause denial of services. Then protecting the agent during the transfer, so as a mobile agent moves around the network, its code as well as its data is vulnerable to various security threats. So there are two known types of attacks, passive attacks and active attacks. Then Android development, for you can see something, what is Android and overview development environment. So Android is an open source software platform created by Google and the Open Handset Alliance, and it is primarily used to power mobile phones. So it has the capability to make inroads in many other embedded application markets. So Android consists of a complete set of software components for mobile devices, including an operating system, middleware, and an embedded key mobile applications, and it has a large market. So Android is a software environment built for mobile devices, and it is not a hardware platform. So Android includes Linux kernel-based operating system. It is a rich user interface. It is with telephone functionality and user application, code library, application framework, multimedia support, and user applications are built for Android in Java. So in Android context, the mobile market where operators are there, device manufacturers are there, and software vendors are there. So mobile network operators want to lock down their networks, controlling and monitoring traffic, and device manufacturers want to differentiate themselves with features, reliability, and price points. And software vendors want complete access to the hardware to deliver cutting-edge applications. So you can see.
So why it is red like this?
But in today's scenario, smartphone and laptop is sufficient to uh, for the business or for do any type of communication. So the manufacturing mobile experience where these are the various smartphones can be using with these, all the things can be do with a smartphone. So Android versus competitors, you can see the Apple INC is there, Microsoft, Nokia, Palm, Research in Motion, and Symbian operating system. So these are the various competitors of Android and Android. So the Android components where Android stack includes a large area of features for mobile applications, and it would be easy to confuse mobile Android with a general purpose computing environment. So all of the major components of the computing platform are including these are the various components like application framework, dynamic virtual machine, optimized for mobile devices, integrated browser is there, optimized graphics, SQLite for structured data storage, media support. These are various image formats or media formats supporting in Android, GSM, telephony, Bluetooth, L, 3G, 4G, Wi-Fi. These are all hardware dependent. Camera, GPS, compass, accelerometer. These are also hardware dependent and rich development environment, including a device simulator, tools for debugging, memory and performance profiling, and a plugin for the Ellipse ID. So these are the various layers. You can see Linux kernel with a display driver is there, camera driver, or flash memory driver, audio driver, Wi-Fi driver, keypad driver. These various drivers, power management and binder IPC driver are there in the Linux kernel. And the Android runtime includes the core libraries and Dalvik virtual machine, and the libraries like Surface Manager, OpenGL, SGL, Media Framework, FreeType, SSL, SQLite, WebKit, libc, and application frameworks for activity manager like window manager, content provider, view system, package manager, telephony manager, resource manager, location manager, notify manager. All these are in application framework, and applications are in home, contact, phone, browser, like so on. So why use Linux for a phone? So Linux kernel is proven core platform, and reliability is the more important than performance. So it is reliable. So because voice communication is the primary use of the phone, and Linux provides a hardware abstraction layer, and the new accessories appear on the market. Drivers can be written as the Linux level to provide support. And Dalvik virtual machine, where user applications as well as core Android applications are written in Java programming language and compiled into bytecode. Android bytecode are interpreted at runtime by a processor known as Dalvik virtual machine. So why another Java virtual machine? So Android bytecode files are logically equivalent to Java bytecode, but they permit Android to run its applications in its own virtual environment that is free and sunlighting restriction, and an open platform upon which Google and potentially the open source community can improve as necessary. So inside Android, you can see an important and recurring theme of Android development is in the intent. So in an intent, in Android describes what you want to do. So this may look like I want to load up contact record, or please launch this website, or show the order confirmation screen. So intents are important because they facilitate or navigation and represent the most important aspect of Android coding. So an intent is a declaration of need, and an intent is made up of various pieces including desired action, data, and category of component. So intent filter is a trigger, a declaration of capability and interest in offering assistance to those in need, and an intent filter may be generic or specific with respect to which intents it offers to a service. An intent is an abstract description of an operation to be performed, and it is most significantly used in the launching of activities where it can be thought of as a view between activities. So the primary pieces of information in an intent are like the general option to be performed, such as action view, action edit, action main. So the data to operate on which, such as a person record in the context database, expressed as a URL. So some examples like action view displays the information about the person who identifies the one like this. Action dial, which displays the phone dialer with the person filled in. Action view, which displays the phone dialer with the given number filled in. Action dial, which displays the phone dialer, or edit information about the person who is identified as one. And action view content context, it displays the list of people which the users can browse. Then dissecting intents, where component name is there, action, data, category, extras, and flags of any sort. So an intent object is passed to context start activity or activity dot start activity for result to launch an activity or get an existing activity to do something new, asynchronous and synchronously respectively. So an intent object is passed to context dot start service to initiate a service or deliver new instructions to an the connection between the calling component and the target service. So it can optionally initiate the service if it's not already running. Then intent resolution, it divides on two groups: explicit intents and implicit intents. So explicit intents designate the target component by its name, typically used by activity starting a subordinate service and launching a sister activity, or implicit intents do not name a target. It often used to activate components in other applications. Late binding applies. The intent filter defines the relationship between the intent and the application. So the specific to the data portion of the intent, the action portion, or both. So intent filter also contains a field known as category, and the category helps classify the action. So the category name category launcher instructs Android that the activity containing this intent filter should be visible in the home screen. So when an intent is dispatched, the system evaluates the available activity services, and registered broadcast receivers and routes the intent to the most appropriate recipient. So Android applications, each Android applications run in its own Linux process, and an application consists of combining of software components including activity, service, broadcast, receiver, and content provider. So the Android application, the structure of a typical Android application and demo one Java like activity, services, broadcast, receivers, content provider go here, resources here, and manifest here in manifest.xml file. Then Android service, where a service is an application component that runs in the background, not interfacing with the user for an indefinite period of time. So start service dot context dot start service, or the context dot bind service, or context dot stop service. We are using this. So Android services, like other applications objects, are in the main thread of their hosting process. So Android broadcast receiver, where if an application wants to receive a response to a global event, like such as phone ringing or incoming text message, so it must register broadcast receiver. Intent filters are there for application register to receive intent by announcing the manifest file, Android manifest.xml file. And broadcast receiver and UI, where it likes services broadcast receivers do not have a user interface, and the code running in the on receive method of a broadcast receiver should make no assumptions about persistence or long run running operations. So Android broadcast receiver, where the some activity send broadcast, and broadcast receiver on receive, broadcast receiver on receive, like this. So these are the various activities. So the Android broadcast receiver intent versus broadcast. So starting an activity with an intent is a foreground operation that modifies what the user is currently interacting with. And the broadcast and intent is a background operation that the user is not normally aware of. So types of broadcast: normal broadcast and ordered broadcast. So then broadcast receiver life cycle, where broadcast receiver on receive, context inti or on receive, or service in conjunction with the broadcast receiver to keep the containing process active to the entire time of the operation. Then content provider. So in Android, content provider stores and retrieves data and make it accessible to all applications. So there are the only way to share data across Android applications, and there is no common storage area that all Android packages can access. So Android ships with a number of content providers for common data types, for example, audio, video, image, personal contact information, and so on. So content providers are the data layer providing data abstraction for its clients and centralizing storage and retrieval routines in a single phase. So a content provider may provide data to an activity or service in the same application space as well as the activity or service contained in other applications. So this is the Android content provider. You can see the various Android application 1, 2, 3 are there, activities are there, the content provider is there, and the SQLite database, data file, XML, and virtual connection or remote store. So these are the various contents. Hold on. So Android manifest XML file, where every application must have an Android manifest file. The manifest presents essential information about the application to the Android system and information. And the Android manifest XML file, where action, activity, alias, present. These are everything available here. So metadata, manifest, usage, SDK. So these are the only legal elements. You cannot add your own elements or attributes. Then among other things, the manifest does the following. So it names the Java package for the application, it describes the component of the application, it names the classes, it determines which process will host application component, it declares with permissions the application, it also declares the permissions that others that are required, it lists the instrumentation classes, it declares the minimum level of Android, and it lists the libraries. So vulnerable to failure, interruption, and eavesdropping, or the security in mobile network, where the mobile computing environment, where ad hoc mobile systems has everything moving and needs survivability from intentional and unintentional attacks. So another research ideas, so integrated ideas from science and engineering of security and fault tolerance, for example, need to provide access to information during failure, adaptability, injection protocols, or deficiency in mobile IP authentication, where authentication is through a home agent, HA, and deficiency in mobile IP key management, where data packets are encrypted before sending and decrypted after receiving. So it requires exchange of secret keys and public keys between sender receiver, and mobile IP does not provide multicast session key management. Uh, so these are the research questions like difficulty in initial authentication or maintaining authentication, or the hierarchical authentication of mobile-based stations, key agility, and the adaptive intrusion detection systems, or fault tolerant authentication in mobile computing. Is the objective is to provide uninterrupted secure service to the mobile host when base station moves or fails. So the focus is on fault tolerant authentication, group key management, adaptable, reconfigurable software or experiments. So mobile IP entities where mobile host MS is there, which can change its point of attachment to the internet from one link to another. Home agent where router on mobile host, home network, which tunnels datagrams to mobile host when it is away from the home. And foreign agent where router on mobile host visited network which provide hardware characteristics, media, or low power and limited computing resource and bandwidth, autonomy, system characteristics are autonomy, network partitions and clock synchronization. Application characteristics are location privacy, mobility, and secure multicast. And the fundamental security services like authentication, it provides assurance of our host identity and provide means to counter masquerade and replay attack, and can be applied to several aspects of multicast. Then integrity, confidentiality, non-repudiation, access control, and cluster, it is a group of servers act as a single source, gives the effect of parallel processor with a large main memory and secondary storage, and largely scalable and efficient and deployed in service provider networks. And the client contacts the front end for the service, and front end forwards the request to a backend, and backend serves the process the request. Then the cluster-based environment. Flat model and tree-based schemes for fault tolerant authentication in mobile environment can be used, and cluster-based enhancement can be used. In future work, the quantifying the priorities for each factor and computing the overall key priority as a weighted function of all these factors, and designing a adaptable database application and partitioning a scheme for secret key database that increases the system performance in future. And the simulation of these approaches and obtaining performance statistics, these are the various features. These are the various references. Thank you.
Sir, is it audible, sir?
Yes, yes.
Sir, thank you a lot, sir. Thank you so much, Dr. Pankaj Dadheech, sir, for your precise presentation on mobile application security. You made some great points regarding mobile app and development, and we know about some of the threats, how we can overcome them. Thanks a lot, sir.
Thank you, ma'am. If there are any question, I am happy to answer. Okay, thank you all.
Thank you so much,
Dr.
sir.
Pankaj. Thank you very much,
Thank you,
Dr. Pankaj.
Thank you.
Yes, sir.
Madam, we can conclude.
Okay, sir. I hope each and every participant got some valuable information in our today's workshop session. Okay, maybe it helps a lot to explore them in an efficient manner. We can continue the session by tomorrow, exactly by 2 p.m. Thanks a lot.